Okay, so number 46, we have a triangle with a side length of 12 and 15 meters. And then the angle between them is increasing at a rate of 2 degrees per minute. So we want to know how fast the length of the third triangle is increasing when the angle between the fixed sides is at 60 degrees. So we have a side 1, which we'll call A, is equal to, side A is equal to 12 meters. Side B is equal to 15 meters. And we don't know side C yet, so we're going to put a question mark. But we do know theta is equal to 60 degrees. We also know that that d theta dt is equal to 2 degrees per minute. And we are looking for dc dt. Okay, so first we're going to draw a triangle. And it doesn't say it's a right triangle, so I'm just going to draw a regular old triangle. And we're going to label 12 meters, 15 meters, C, and theta. So first thing you want to do is change this and this into radians instead of degrees. So 60 degrees is pi over 3 radians, and 2 degrees, we can do it down here. We can say 2 degrees, do a little over 180. So that's kind of cool.
I know you.
Hi, Tita.
Where you up to, Erwin?
I'm recording a video for Noelle.
Sorry, did they just make it loud for you?
Maybe. It's fine. They'll just hear this conversation.
It's fine.
Okay. So it's going to be equal to pi over 90 radians. So we'll write that over here. Pi over 90. So then, now that we have that, we need to figure out C. So to figure out C, I'm going to take that over here. Maybe we'll use a different color. We are going to use the law of cosines. So we're going to equal C squared is equal to A plus B squared with B squared minus 2AB cosine C. So, and we know this, let's go over here. This cosine C is going to be theta because we can relate these two. All right. So back to our pencil. It's a little smaller. Okay. So we can solve for C by saying C is equal to 12 squared plus 15 squared minus 12 times 15 times the cosine of pi over 3, because this is going right here. And then we're just going to square root that all. So that's going to be C is equal to the square root of 396 minus 360 times the cosine of pi over 3. We know that the cosine of pi over 3 is 1/2. So we can just go ahead and say this would be 180. This right here is going to be 180. So it's going to be 396 minus 180. That's going to be equal to 189. And we can split that up into 9 and 21. So it can also be equal to the square root of 321. All right, so that's C. So we can go ahead. So we can go ahead and erase this question mark and now replace it with 3 square root of 21. So now we have to figure out, let's let's do it in dark blue. We've got to figure out DC, DC. So to do that, we're going to use the law of cosine. Okay, so we are going to keep going. So we have c squared is equal to a squared plus b squared minus 2ab cosine of c. And since both a and b never change during this problem, we're just going to go ahead and stick them in before we take the derivative. So we're going to have c squared is equal to 12 squared plus 15 squared minus 2, 12, 15 times the cosine of c. So we're going to simplify that really quick. So that's going to be equal to 396 minus 360 cosine of c. Now we're ready to take the derivative in respect to time. So we're going to have to use the chain rule on c squared. So it's going to be 2c dc over dt is equal to, and so this is just going to go away. And so now we are going to have, we're going to have this 360 is going to stay, but since cosine translates to negative sign, we're just going to go ahead and get rid of this negative sign. So it's going to be 360 times sine c, and then you have to use the chain rule. So sine theta, let's have this be a theta, d theta over dt. Okay. So now we're going to go ahead and plug in the things we know. No, we're not going to plug in the things we know. Sorry. We're going to simplify first so we can get rid of this 2 and make this a 180. And then we can go ahead and move the c over to the other side. So dc, which is what we're solving for, over dt, is equal to 180 sine of theta d theta over dt is equal to, over c. All right. So now we're just going to keep on plugging things in. So I'm going to go ahead and take this problem. We're just going to shoop it up here. Actually, yeah, we're going to shoop it up here so we have a little bit more room. And so we can look back at our original problem. So dc over dt is going to be equal to 180 sine of theta. So we know theta is pi over 3. So sine of pi over 3 times d theta over dt, which we saw was 2 degrees over a minute, which we changed to pi over 90 radians per minute, divided by c. So c is 3 square root of 21, which we solved for earlier. So now we're just going to, we know sine of pi over 3 is equal to square root of 3 over 2. So we can just get rid of this 180, get rid of this 2. Actually, let me change colors for this. We can get rid of 180, 2, and 90 all together because 180 divided by 2 and 90 is 1. So now we have square root of 3 over 3 square root of 21, which we're going to simplify by multiplying square root of 3. Oh, we still have a pi too. So we still have a pi. We still have a pi that's attached to this. So pi square root of 3 over 3 of square root of 21. So we're going to simplify it by multiplying by the square root of 3 over square root of 3. So that's going to give us pi, 3 pi over 3 square root of 63. So these can be canceled out. So then our final answer is pi over square root of 63, sorry. Square root of 63. And we need to attach a unit to this, and we know it's for this side C, and so it's going to be meters per minute. We're going to attach meters per minute to this. So that is our final answer for what is, so we're going to write the final statement because we were looking for the length of the third side when the angle between the fixed sides is a fixed length is 60 degrees. Okay, so we're going to write the third side is increasing at a rate of pi over 63 meters per minute when the two sides are at fixed lengths of 12 meters and 15 meters, and when theta is equal to 60 degrees and is changing at a rate of 2 degrees per minute. All right, there we go. That is it.